Hello everyone, I am Yogiraj and I am currently Data Science and Business Analytics intern at the Sparks Foundation. So I am going to explain about today's task, that is prediction using supervised ML. So in this particular task, we have to predict the percentage of a student based on the number of study hours. So let's go to the code. Now at first I am importing all the necessary libraries. Those are the NumPy, Pandas, Matplotlib, Seaborn, etc. And next I am taking the data that is present in the form of a list, and I am creating a Pandas data frame for the columns with the columns hours and scores. And after creating the Pandas data frame, I am converting this data frame into a CSV file using df.toCSV command. And now let's read the CSV file. When I am reading the CSV file using the pandas.read CSV function, and as we can see, these are the first 5 rows of the data of the CSV file or the data set. As you can see, number of hours studied is 2.5, the score is 21. If the number of hours studied is 5.1, the score is 27, etc. And now let us find out the data types of the data set. For that, I am using the .info command, and as you can see, the hours and scores both are float and int data types. And next, I'm using .describe command to find the statistical summary of the data set. That is, what is the minimum value in hours and what is the minimum value in what is the standard deviation in both the columns, what is the maximum value, and this is the statistical summary of the data set. And next, let's check for the missing values. So as we can see, there are no missing values in the data set. Let's check for the outliers, since these are the important things which you have to check in the exploratory data analysis part. And to check the outliers, I'm using the box plot command from the Seaborn library for the column hours. And as we can see, this is the box plot which we have obtained for the column hours column. And there are no outliers since there are no values present outside the interquartile range. There are no values since there are no values present outside the interquartile range. As you can see, there are no outliers in this specific column. Similarly, let's check for the scores column. Since there are no, again the same scenario, since there are no values outside the interquartile range, we can say that there are no outliers present in this data set. Since there are no outliers nor the missing values, you can directly jump into training and testing, splitting our data into training and testing. There is no need for data cleaning. And before splitting into training and testing, we have to identify the dependent and independent features in our data set. So the dependent feature in our data set is the scores obtained, and the independent feature is the number of hours studied. So I'm initializing the independent feature into the x variable and the dependent features into the y variable. And now I'm splitting the data set into training and testing with the training size as 80% and the testing size as 20%. And now I'm calling this linear regression. Using this linear regression algorithm, I am going to predict the scores based on the number of hours studied. So I am calling this linear regression algorithm from the sklearn library, and I'm fitting the training and testing training data set into the model first for the training purpose. And after that, I am predicting on the trained model. I'm using the trained model to predict on the testing data set. So here all the predicted values will get stored in the y_pred variable. And now let's check the accuracy or the correctness of our model. To be specific, since this is not a classification algorithm, we cannot use the term accuracy. We have to use the term R2 score or the adjusted R2 score. So here I'm using the R2 score as the evaluation metric, since this is a regression model. So the R2 score we obtained is 0.94. It means that our model is pretty much working well. And so now let's plot the best fit line, that is the linear regression fit line. So these are, as you can see, I have plotted the best fit line. These red values are the data points, and this line indicates the best fit line. And another thing, in the question it is asked that if a student studies for 9.25 hours, what is his predicted score? So as you can see, since our model is trained, we can use to predict with this data value, that is 9.25. So as we can see, the score of a student if he studies for 9.25 hours per day is approximately 92.78, that is 93. So he is expected to achieve 93 marks. He will achieve 93 marks if he studies 9.25 hours per day. And now let us save the linear regression model using pickle file. That is, I'm importing the pickle as pkl, and I'm saving the model file as model.pkl. So this is the task 1, that is the prediction using supervised ML. That is prediction of scores based on the number of hours studied. Thank you.